In this video, we'll be talking about differences between the wet cell battery and the dry cell battery and the chemistry behind how these batteries work. So, you may not have heard of these particular types of batteries before because only what they show you in the ads and in the marketing programs is, the battery brand, the AA battery. They always say alkaline battery on the label, for example, but they usually don't say wet cell battery or dry cell battery. So here's what the definitions of these two types are. So the dry cell battery is an older basic term describing any battery that has a zinc cup design. So there's a large cylinder. That's why the battery is cylinder shaped, because there's a cylindrical zinc cup containing a high quantity of the element zinc inside that battery. And so the dry cell battery, how it works is it goes through a reduction and oxidation chemical reaction. And it basically uses up the zinc cup contents over time through a reaction and generate energy. And that's why the battery eventually runs out of energy and dies, because you use up all of the zinc in that zinc cup. So here is a close-up on the diagram of the innards of a dry cell battery. So going into a bit more detail here, we have our reduction reaction and our oxidation reaction. So if you aren't familiar with these particular chemical terms, a reduction reaction is one in which you have a gain of electrons. So this may look complicated, but basically what's going on here is we have a reaction going on involving the central zinc cup and some other elements which also are contained within the battery, like zinc chloride and ammonium chloride. So, and these different elements play different roles in the oxidation-reduction reaction that helps to power this battery. So, in the dry cell battery, we say that the zinc cup is the reducing agent. Now, if we have a reducing agent to get energy, we must also have an oxidizing agent. In this case, the oxidizing agent is the paste, which is made up of NH4Cl, which is what we're talking about, the ammonium chloride, or the ZnCl2, the zinc chloride, or the magnesium, NNO. And we also have a membrane surrounding this the zinc cup. So, but dry cell batteries are not very good at lasting over a long period of time. They tend to run out of their zinc, and they don't do well in unfortunate storage conditions, which is why we have the higher quality and more expensive wet cell battery. So the wet cell batteries are the typical ones that you see in the stores, the AA batteries, the AAAs, the alkaline ones. These are the zinc ones. Over here we have the wet cell batteries, these are the alkaline batteries, and you find these in more advanced products around the household, requiring a bit of a longer battery life than the dry cell batteries. For the wet cell batteries, you can find them in digital cameras, in old phones, like handheld radios, something like that. The dry cell battery, on the other hand, is really only found in fan remotes, for example, or TV remotes, where you don't really have a serious need for a high amount of power. So the wet cell battery works a bit differently. So instead of having this huge zinc cup inside the battery, we still have oxidation-reduction reactions here, as you can see, but they involve completely different elements and components. Mainly, we're using, we have a liquid form of H2O or hydride, and this is playing a major role in alkaline batteries. So the reason why wet cell or alkaline batteries don't run down as quickly as dry cell batteries is the wet cell batteries, they don't involve the zinc depleting ions that are found in this particular reaction here. So there's nothing to deplete the zinc within the wet cell batteries, so they last longer. However, eventually the membranes within the wet cell batteries do run out, or they get depleted. It just takes a much longer time for these kinds of batteries to go bad than dry cell batteries. So, there's a brief overview of the differences between wet cell batteries and dry cell batteries, and how they work on the inside.